bottom, draw the graph of a polynomial function whose degree is 6. I started you off with a 1. My only hint is, remember, when you're making those pictures, you start adding it on to the left. Start coming this way. I did the first part, a 1. That's nice and easy. I'll do a 6. See what you remember. And then we'll... so there we go. Anybody happen to know the degree? Okay, Philip, okay, Alvin. You say 6? Okay. Tell me how you got your 6. Well, we'll say which ones, that way I'll know what you're... Okay. Very nice. So if it's in factored form, finding the degree is nice and easy. You just look at the degree that's on each one of these, what are called linear factors. Why are they called linear factors? And this is actually important because they use that phrase, linear factors. Factors because they're trapped inside of a parenthesis. Yeah, that's no big deal. Linear because when you look at the x's inside the parenthesis, if the x is raised to the highest power of 1, not outside, there's a 2 outside, yes, there's a 3 outside, but inside, if the x's exponent is a 1, then we call it a linear function. It's a single when it's time to draw through. I'm going to skip down to the number of solutions to x-intercepts. Don't answer Jessica. Someone else. How many solutions or x-intercepts are there going to be? 6. Yeah, 6. Those two guys always match up. I don't know quite why they don't put them right below each other so that it would be that. Well, we'll try someone different, and then we'll let you two come back in. So hold right now, Oswaldo and Jessica. On this one, what is the orientation? Is it positive or is it negative?
Positive.
It's positive. How can you tell?
Because it's all negative.
There would need to be a lead negative here. You'd have to see it to tell you that the orientation is going to be negative. And that just tells us when we start in our picture, if it's negative, well, you don't always start from the negative section. You draw your original picture, which I'm going to draw a 6 here. And then if it's negative, you flip it down so that when you're drawing your picture over here, you can do that. Again, on the test, it does appear that instead of going all the way up to 6, they do maybe a 4, maybe a 3. So the good news is this is the heavy version of it. And finding out things is no big deal. All right, we got a positive orientation. Let's see, there are 3 roots. I guess everyone can get back in, but I'll start with Marcos, just because Marcos or Tess. Let's see if you were guessing. If you were guessing, Marcos, one of the roots, where would you guess? What number would you guess for a root? And then Tess, I asked you to guess. Wait a second.
2.
2 is close. I like 2. We just need the sign to be different. And Tess, can you guess one of the roots? Great. Okay. And again, when you say roots, and I wish I would have been saying this from the beginning of the unit, this idea of the x-axis, you're walking at ground level. Okay. A root is always when does something hit the ground. Like if you're dribbling a basketball, every time the ball hits the ground, that is a 0 or a solution. Hey, where did it do it? Oh, you mean where does it have root? Oh, he bounced right here at 1. He bounced here at 2. Or if it's a roller coaster that goes up in the air and goes through the ground, where does it hit the ground? So we got a 2, but a negative. We have a 3, but a positive. And then we have a 5, but a negative. To know in math talk what root is also, what number does x need to be? I really should put it under the x. To make this little pod equal 0. Oh, well, if x were a -2, -2 plus 2, oh, that's 0. Oh, if 3 was a positive 3, 3 take away 3, okay, that's 0. And that's why it's always the same number, the opposite sign. So getting the roots, which standard 5, they're going to have you try and get the roots in 2 different ways. Well, 3, but one of them I'm probably going to eliminate. One of them is they're going to give you something that looks like this, and they're going to say, hey, what are the roots? You just plug them in, or you write them down, boom, you got it. The other way we're going to do it is on the calculator, which is, or on the computer. You're going to type in the function. You'll see wavy lines wherever it hits the x-axis. You just write it down. The only difference between where it hits the x-axis and this version, This version, yes, has to be the opposite sign, the opposite sign. But if I were to just draw a line like this, let's see if I can get one to hit just somewhere right here, boom. If someone said, hey, what's the root here? It really is 2 comma 0. It's not a negative, not the opposite. To go from the factor form to the picture form, yeah, you got to do the opposite. But if we just give you the picture, you just plug it right off the picture. In any case, let's see if we can go to the next step. Next step, we're writing these roots down. I heard a negative 2 comma 0. You have to write it in, what's that word I'm called, coordinate form. We have a 3, and we have a negative 5. I hope some of you are feeling like this isn't hard, it's just a lot to remember. And it's true. Fortunately, on the test, it doesn't look like they're making you build all of the stuff except for maybe one time. And I think, again, it says maybe a 3 or 4, not a 6. Let's try the single, double, triple thing. Anybody know what the negative 2 is going to be? Single, double, or triple?
Single.
Yeah, single, no big deal. If you answer, don't answer the next one. Number 3, single, double, triple?
Double.
Okay, or just keep answering. And then the 5?
Triple.
Yeah, it's a triple. One thing I'm going to do with the single, I'm going to put linear inside. Because they use that phrase, they don't do the single, double, triple. If you write single, double, triple, I will accept it. But sometimes I say, please find all of the linear factors. Linear factors. Linear factors. If they use factors, they mean, hey, I need it inside of the parentheses. If they say the linear zeros, then it means it's outside. When you hear the word factor, you just know something has to be inside of parentheses. All right, y-intercept. Let me skip down to the picture, and then we'll get this y-intercept. Hey, if you're drawing your 6, 2, 3, 4, 5, 6. Why is that important? If you have to draw this picture now, which we are going to sketch, you need to know how many wavy lines technically are in the middle. But more important than that, what are the ends doing? Are they starting up high and then they're zipping in and then doing all their stuff? Or are they starting at the bottom going up? Okay. One other thing with this, the orientation here is positive, so I'll put a plus. If the orientation were negative, then that same 16 would just now flip down. How many inside? How can I do this? There's 2 pointing up, so now they're going to be 2 pointing down. All right. So if this were a negative orientation, the 6 and the 1, that's what they would look like. All right. You got calculators. Hey, somebody help me with the 2250. Notice what she did. She put it inside in the coordinate form. It is true when you do the y-intercept here, you have to do it that version. All right, these are all the pieces we're about to try and draw this thing. Hopefully it doesn't feel super hard. But the drawing goes like this. If you want to get some points, start by putting the points at those, what do they call it, at your zeros. In other words, when the thing hits the ground. Negative 2, it hits the ground. At 3, it hits the ground. Ground 0. And at negative 5, it hits the ground. 3, 4, 5. I'm going to put my numbers right below it just so I have them. You're going to build some small ones in a second. This is just to get it all together, to hit several standards at once. All right. And again, I'm going to try and write what standard goes with what. All right, so here we go. It's a W, or rather it's a 6, so it's coming down through. When it hits a 5, 5 is a triple O, so it has to bend. I'm not going to undo. Let's see if I can make it bend now. Bend. See how it kind of has to bend? That's how you do a cube. Bring it back up. Am I going up through the 2? 2 comes next. 2 is a single. Single can just go straight through. Now this part you will need to know. There's no way around it, even if it's a small one. You got to know what to do when you hit the points. That's why you have to do the single, double, triple. That y-intercept is at 225. I'll just put a 2250 because again the scale would be way up, super high. So I'm just going to go up and I'll put a dot right under there and go through that. Once you cross over, we come back down to that 3. 3 is a double. Doubles are popular, singles are popular. So definitely know how to do a double, definitely know how to do a triple. A double, it bounces off of it. And now it's heading back up. Let's pause there, have you take a look at x's. To get the y-intercept, we put 0 in the place of the x's. And so by putting a 0 in the place of the x's, that's still bad, you'll wind up taking this number, raising it to the power, this number, raising it to the power, this number, raising it to the power, and multiply those 3 answers. So if I were actually doing it, 2 to the first power is a 2 times 3 to the negative 3 to the second power is a 9 times 5 to that is 125. And if you multiply all that together, you want it with a 2250. Here's a linear factor. Just underline all 3 of the linear factors. The guys here, please, I don't know if you can write it somehow, put the zeros. All right, and what I'm trying to show you is the test has 5 different segments, but they kind of overlap with what the other segment is asking. All right, let's talk about the end behavior so that standard 2 you can have it. Basically, the end behavior asks, this is your x, this is your y. Hey, with whatever's going on with these arrows, tell me what's going on with these arrows, the end behavior, what's happening at the end? So the first thing you say is this end behavior. As x goes to the left, all the way, all the negatives we call those negative infinity, as it goes this direction. What does this blue arrow seem to be doing? It seems to be going up, or it seems to be going down? Well, I can tell the blue arrow is going up. And you only have 3 choices. Y is what we're talking about with up and down. Y goes towards what number? Anyone know? This blue arrow keeps going up and up. What number will it finally get to? Positive infinity. And behavior only uses infinities as their as the numbers they use. So as x does something, positive or negative infinity, y does something, positive or negative infinity. Do me a favor. We just did what happens when x is going this way. On the next line, please write down the opposite. When x is going that way, I won't tell you what to write. What happens to the arrow? And that will be called your end behavior. What are the arrows doing on either end? When they go towards negative infinity, what's the arrow doing? As we go towards positive infinity, what's the arrow doing? All right, here goes. What does someone put in the green? What is the y doing? As we go this way, what does this arrow seem to be doing? Going up or down? Yeah. Up is regular talk for going to positive infinity. All right, that's the end behavior. Let's imagine this arrow didn't go up. It came back down. It's going down this way. Oh, as x goes to positive infinity, y goes to negative infinity. There's only 2 choices. Up is positive infinity, down is negative infinity. So it's a point. So if you understand what just happened there, you just got a 3 on standard 2. If you don't understand what's going on there, that's fine. You still get a 2, as long as you can do the graph. And you can get the zeros. Well, you need to get the zeros to do the graph anyway. So if you can do the graph, standard 2, you're done. If you can say what's happening on the end of each one of them, then you get a 3 in that. I think what is a 4 on that one? Let's see, 4. I can write the equation of the function when given a graph. We're going to try that in a moment. They can give you a picture, and you have to back up, take off the zeros, the right numbers, bump up to the next level, put them in parentheses with the opposites, and then depending on whether it bounced on it, went straight through it, or bent through it, put a 2, a 1, or a 3. So you're going to go backwards. All right. Lines up with the 0 as well. So 0, 0. The sketch on this one is a, it's a 2. So I should note, I do make these edges hard, but technically they're rounded. But for the purposes of this, as long as you kind of have it looking right, I'll be okay with that. How do we draw that picture? Let's see. And that's why I didn't know where to put things. 0 and a 2. 1, 2. So 0. I'll put my 0, 0. And then I have a 2. It's a 2. So this is V. Comes up from the top. So I just come through 0. They're both linear, so it just goes through them straight. So it looks just like this. I come through. When do I turn the corner? It kind of doesn't matter. I'm sure there's a way to find out where you turn that corner. And as some of you know, you remember y equals x squared. If this is that same quadratic, you want to ask about as you look at that one. Do this 2 on this one. Put down end behaviors. This end behavior thing will make up for the last one we didn't do, which is almost exactly the same thing. End behavior x, x, y, y, arrow, arrow. Watch this. I'm going to put in the infinities, and really all you have to decide is whether it's positive or negative. Your hint for the x's, first one is positive, one is negative. The x's always do one or the other. Like, oh, I start with x as positive, and then the x is negative infinity. It's the y where you have to look and think. But the infinities, they all go. The x's always positive and negative. It's only the y's that you have to decide, okay, so what is it doing when I go this way? Is it going up in the air or down to the ground? And when I go to the right. All right, because of our time, I've got to put this in. I do not want to do the next one. I'm going to do the next one. Shoot. Because there's one where you have to draw the picture, and it probably looks like the next one. Here it goes. When x is positive, y is positive. Let's do the negatives. When you're going this one, the x is negative infinity. You can see the y is going up to positive infinity. And on the second row, when x is going to positive infinity, again, you can see the y is also going to positive infinity. End behavior gets you a 3. Don't need it to get a 3, but why not if it's that easy? So we got y. After this one, we're going to go backwards. We're going to give you a picture and have you produce some of the original. So I'm giving you the original, x minus 2. Minus 3. The next one I'm going to give you, which it will actually be a handout, you're going to go from the picture back to this, and hopefully enter in all the other pieces. All right, do this, guys, as quickly as you can. The degree, orientation, solution. That part's now automatic. Roots. We've got 5 more minutes for it to switch to the computer. Roots, one intercept, and behavior. For sketch. You should have extra sheet of paper for this one. start you off with the sketch we know. What one looks like. I'm not trying to give you enough time to. And there's 2 and 3. Common peek to see what you sketch as that. The other thing is going to start going towards that that very first dot. And then here the hint is when it leaves the last dot. Let's see. Sketch a picture. They're going to have you try and sketch a picture. You're going to try and oh, these are singles, so it doesn't bounce. Let's see if this thing works. All right, I'm going through it, even though I know some of you didn't finish it. All right, so it goes through the first one, and then it curves down at some point. How do you know when? You just decide, and then as long as it has the waves. So there's, not only is that a real 3, but it looks like a little fake 3 in the bottom. Anybody want to ask anything on this one? You're about to go backwards in a second. I'm about to give you a handout. And you're about to go from the picture. Imagine you were going from this picture, though. If I were going from this picture to a real thing, to an equation, the first thing I would do is, because you're about to do it backwards, I would write down the coordinates of the point, so I know this is 0, 0. This guy here is 2, 0, and this guy here is 3, 0. Why does that help? Because again, now I automatically have my roots. By automatically having my roots, I automatically know where I got them from. I had to get them from some parenthesis thing. 0 is always a letter. That 2, I know it's going to be with the opposite sign. That 3, I know it's going to be with the opposite sign. Here, because it went straight through, it didn't bend, I could put kind of 1s here to say that it's a single, or I don't know how you do it. You put single. Somehow you're going to have to indicate that. Like, wow, why do you need to indicate that it's a single or whatever? Because up here, once you get these, okay, I got my roots. I wrote them as factors. Now you decide, should I put a 2 on that, or should that have like a 4 on it? Or you have to decide, well, if they're all singles, they all have invisible 1s. If you chose to write the 1, I would accept that. Would you like to read more details? No. All right, so then, let's give you your paper. This one is standard. We're trying to do this one in the interest of time because there's a couple other things we need to do different than this. But this will be one that you get to study from. The minute you put a dot there at 2, they're one of our zeros. And I didn't notice this second one, this last one kind of has it. At 3, we got our 3, 0. So this piece here, I would expect everybody to be able to do. This part here, he's kind of tricky because he's 2 things at the same time. Not only is he the third of the 3 zeros, it hits the ground here, it hits the ground there, it hits the ground there, but then also, he also hits the y, so he's the y-intercept. So it turns out, if I did my 3 roots, 0, 0 always comes from an x. The 2, it comes from a -2. And the 3, he comes from a -3. Take a look at that so far. And it looks like exactly this thing right here. What's the difference between ours and that one right there?
X minus 2 needs to be squared.
This x minus 2 here, notice that it bounces, so that needs to be squared. Write that down if you didn't have it. And take a close look at it. Now, this is all they're asking for this one so far. I'm going to add one other thing that they asked me on the test about it. And let me see, this is a standard 1, so how many do we need to get a pass on this? Find the domain of the graph, fully explain its real context by describing. All right. Here's the equation. Let's find the domain. Now, standard 1 asks, or standard 2 is going to ask you just to get this thing here. Standard 1 wants something extra. Here's what standard 1 wants. Okay, what's the domain of this roller coaster? That's math talk. Let me see if anyone knows. What does that math talk mean in regular talk in English? What's the domain of the roller coaster? Kind of infinity, like I kind of go on and on forever. For real life examples, the domain always has to be restricted. Restricted means, oh, it has to start somewhere and it has to stop. If it's a roller coaster, it really has to start right here, where you get on at 0, 0, and you ride it, and then you get off here at the end at 3, 0. Okay. So do me a favor, write down the domain for this case, and I will let you be as specific as you want to be. Purpose of this roller coaster, domain. Under it, just so you can have regular talk, beginning, begins to end, beginning to end, beginning to end. We're going to write it in bracket form. It begins at 0, and it ends at 3 for our purposes. If you did 3.5, whatever, I would take it. Yeah, I get it. We include, we use these brackets. The rule basically here is if ever you use regular numbers, you use the brackets. There's a certain time when you wouldn't use them if you ever use infinity. Let's say, oh, this right goes on forever. And regular numbers get brackets, infinity get the little parentheses. Okay. So there's the domain. They're going to ask you just that. Any questions about finding the domain? I think one other question they're going to ask you is something along the. Go ahead and try and find your zeros. Your hint is that the letter I should wind up being part of the answer. When I do mine, we'll see. All right, your ABC, of course, my recommendation is if ever you're putting in letters, write parentheses for the number that you're going to replace in there. All right, A is 2. Sorry, yeah, A is 2. Just put it in the wrong place. A, B, C. A, 4, 6. B, where are you, B? B is a 4. A, you are a 2. Oh, okay, I never noticed that. Put in the same number, and then the last guy. Oh, all these are what the hell? No way. Patterns. And then we start doing the work. Let's see if everybody's there. Yeah, everybody's there. So -4 plus or minus, oops, you're a square, sorry. I'm going to make you a 16. What are you? 12 times 4 is a 48. All over 4. -4 once more. What was 16? Oh, I guess I can just do that. You're a 2 and a 1. Is it 32?
Yes.
All right. This is the part I want to get to, and actually I want to put that minus sign in red, because that's the big deal here. Obviously, you've done this one before in any formula. Here comes the big deal. There's more that can be done to break down this 32, but for my purposes, I'm going to start with you just putting the I, and I'm going to try and go further, but if you get to this next line, then that's the main thing. Not whether do you know how to break down radical 32, which I'm going to show, so that for those who need to know how to do it, you'll be reminded. But this next line goes like this. How did we get rid of this negative sign under radical? You put an I. Everything else I'm going to keep the same color so they can see, oh, shoot, the only thing that's changed is that that minus sign turned into an I. How did that happen? That's the big deal right there. If ever there's a radical, a negative sign under the radical, like that, after you do your work, you bring it outside, and voila, you win. I'm going to give you 3 of these. I'm going to break this down, this 32, just so that you can go the full version. I might be able to give you just the 2. This is under, which one is this is standard 3. Please write down standard 3 on whatever paper you're doing right now. You can solve 2 out of 3 to get a 3. Get 3 out of 3. I don't know if 4 will be possible. Okay, let me actually take them to the last. Technically, what should happen to get that 32 out of there? This is technically what should happen with the 32. At this point, I want to give you some credit, but here's what's supposed to happen: radical 32. When it's not a perfect square, you check to see if any of your perfect squares can divide it. What does it mean? Perfect squares: 4, 9, 16, 36. You only need 4 of these guys over here. Usually once you do 4 of them, one of these guys is going to divide evenly into 32. Now, here's the rule. 4 will usually go into one of the even numbers, but you always check on this short list of 4. Oops, you should be at 25, sorry. The short list of 4, you check to see if that 16 will go into 32. You might get lucky. And in this case, you actually do get lucky. 16 can go into 32. So when you're breaking it down, the first number is always off the special list. The second number is whatever times that first number will give you that. Happens to be a 2. All right. Put it in there. You take the square root of the first piece. Square root of 16 is just a 4. And the square root of 2 is just stuck. This is a 2 level. What I'm going to do next is a 3 level. If you can do a 3 level, go for it. If you can just get to the 2s where you can get this out. If the negative sign stays inside, then it's a 1 level. You don't get any points. It comes out, you're at a 2 level, and then this is a 3 level. What does a 3 level look like? It looks like this. The -4, plus or minus. That I. This 32 turns into really a 4 radical 2. So let me see if they can feel that 4 radical 2. All over the same 4. And then there's the last step. Put a star here so some people can go like, okay, I can get to this step. This other stuff, I don't know about that. The last step is this. If ever the 3 numbers that are outside can be divided by the same number, in other words, oh, what's the number that goes into 4, 4, 4? It happens to be 4, but sometimes it can be like a 16, an 8, and a 4. It's not always going to be the same number. Basically, you have to reduce it by finding a number that goes in all 3 of them, and then dividing each one of them by it. In this ugly case, thank you for making it so ugly, math people, 4 can go in all of them. 4 goes into 4. Oh, this is terrible. We need to get to the computer. 4. So what does the final answer actually look like? Watch this. -1, I apologize. Plus or minus. And I. That's it. There's no bottom. That turned into a 1. Oh, that is ugly. I do apologize for that. Let's see if I can get it back. Plus or minus. Oh, man.